Hey Algebra 2 students, this is Miss Prater and I'm going to do a quick review for Unit 4. I'll be sending this out if anybody needs help with anything in Unit 4, any quiz, and then the unit test. So number 1 is saying the table shows a set of ordered pairs and for a polynomial function f, and that says what is the degree, which means highest exponent. What is the degree? So on this one particularly, I looked into Desmos to see if I could type in the table. I know in TI-84 I could type in this table and of x and y values. So these just represent ordered pairs. So this is the point -3, -32. This is the point -2, -9, and so forth. So I could type it into a TI-84, but I know this year TI-84s were not in your supply box from Alva, so I'm just going to do a rough sketch, and we can look at how many turns or curves this graph makes, and we can determine the degrees. So this isn't going to be perfect, like I'm not really going to graph left 3, down 32, but if I go left 3, down 32 is going to be way down here. This is left 2, down 9. So we'll just pretend 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll say it's about there. We don't have to be exact on this. We're just going to get an idea. -1, 0 is on the x-axis. 0, 1 is on the y-axis. 2, 3 would be somewhere right here above the above the x-axis, and then 3, 16. So 3 and then 16 would be somewhere up here. So again, you're just using, this is your x, f of x is the same thing as the y value, and you would just get this sketch. So when I connect my points in order from left to right, I'm getting what we call a vertical, or I've taught this in classes, a vertical snake. So this is a cubic function. So anytime you have something that looks like this, it's a cubic function, which means it has a degree of 3. If we would have graphed and gotten a line, then that would have a degree of 1. If we would have gotten a parabola, a U-shaped graph, that would have a degree of 2. So to me, I would just kind of sketch it out and see what it looks like. All right, number 2 is asking us what is the remainder. So this is, you can either use long division or synthetic division. So I think on this one, I'll do long division, and on the next one, I'll do synthetic division so you can see an example of each. What you're dividing by goes outside the house. What you're dividing into goes inside the house. We do want the exponents to go highest to lowest. If I'm missing, let's say I didn't have an x squared, I would have to put in plus 0x squared. This is where you would have to put in your placeholders. So we would divide here. We would start with just your first term. X divides into 3x cubed, 3x squared times, and then we would multiply 3x squared times x to get 3x cubed. 3x squared times -1 to get -3x squared. We would put everything that we got when we multiplied in parentheses and subtract. So the 3x cubed minus the 3x cubed, those should always cancel if you divided and multiplied correctly. And this is a -1x squared minus a -3x squared, which is going to end up being a plus 3x squared. So that's going to give us 2x squared. Bring down the next term, and then we're ready to repeat that process. So that's divide. X divides into 2x squared, positive 2x times. 2x times x is 2x squared. 2x times -1 is -2x. Put that in parentheses and subtract. 2x squared minus 2x squared will cancel. -9x minus -2x is really -9x plus 2x. That's going to give me -7x. Bring down the last term, and that means we're dividing for the last time. X divides into -7x, -7 times. -7 times x is -7x. -7 times -1 is +7. put all that in parentheses and subtract, and then whatever you get right here after subtracting is going to be your remainder. So negative 7x minus negative 7x will cancel, and 7 minus 7 will cancel, so our remainder is 0. So they're asking for the remainder, and so your answer here would be 0. Number 3 is asking us to divide, and this time we'll do synthetic division. So our first step in synthetic division is to take what we're dividing by, the x minus 3, set that equal to 0 and solve. And that's going to give me x equals positive 3. I'm going to take the positive 3 and use that for my divisor. So that's going to go on the outside. Remember, with synthetic division, you take away the variables and only use your coefficient. So I have a 1 for my 1x cubed. I have a negative 8 for my x squared. I don't have an x term, so I'll have to put in a 0. And then I have a 2 for my constant. We'll leave this second row empty. We'll draw a line. We'll always drop down that first coefficient, and then we start the process of synthetic division, which is just a fake way to do long division, and that process is multiply. So 1 times 3 is 3. And then we combine negative 8 and 3 to get negative 5, and then we do it all over again. Negative 5 times 3 is negative 15. Combine. Negative 15 times 3 is negative 45. Combine, and the last number we have is the remainder. Now they are not just asking for the remainder here, they're asking for you to write the answer that you get. So we've got to use all these numbers. We've got to put our variables back into our problem. So to do that, we go to the highest exponent. We subtract 1. So 3 minus 1 is going to give me 2. So this first coefficient is going to be 1x squared. So 2. I'm going to go 1 degree down from that 3. If this were a 4, I'd do 4 minus 1, and I'd start with an x cubed. But since it's a 3, I'm going to do 3 minus 1, so it's going to be 1x squared minus 5x minus 15. My remainder is negative, so I'm going to write minus. And then I do 43 over the original divisor. So we're looking for x squared minus 5x minus 15 minus 43 over x minus 3. So it's going to be that last one, x squared minus 5x minus 15 minus 43 over x minus 3. So number 2 is an example of long division. 3 is an example of synthetic division. If they don't tell you which method to use, you definitely can choose whatever you think is the easiest. Number 4 is asking us which of the following binomials are factors of the polynomial. And this particular problem will straight up factor. So if I count the number of terms, I have 4 terms. So that's a clue. When we studied factoring in Unit 3, that's a clue that we factor by grouping. So I'm going to start with grouping. So I'm going to rewrite the problem out here. X cubed plus 4x squared minus 9x minus 36. When we're grouping, we usually have 4 terms. We could have more than 4. Usually it's an even number of terms, but most of the time in Algebra 2, it's 4 terms. We group the first 2 terms. We factor out the greatest common factor, which is x squared. We get x plus 4. The GCF between these 2 terms could be positive 9 or negative 9, but remember, with grouping, you want what's inside the parentheses to be exactly the same. So that tells us we'll have to factor out a negative 9. And that's going to leave me x plus 4, and I want what's inside those parentheses to be exactly the same. I can then factor out my common group. That's going to leave me with x squared minus 9, and then x squared minus 9 is what we call the difference of 2 perfect squares, and there's a formula for factoring the difference of 2 perfect squares. It's a plus b times a minus b. A is going to be the square root of x squared, which is going to be x. B is going to be the square root of 9, which is going to be 3. So x squared minus 9 is going to factor into x plus 3 times x minus 3. So these are my 3 factors, and I'm selecting all that apply. So x minus 1 is not a factor, x minus 3 is a factor, x plus 3 is a factor, x minus 4 is not a factor, but x plus 4 is a factor. Sometimes your problem will factor just like it is. Other times you'll have to use the rational zero theorem to find a factor to begin with, but 4 is a little bit easier because it will go ahead and factor just like it is. Number 5 says, which statements are true about the polynomial function? So it says that x minus 1 is a factor. So if x minus 1 is a factor, then that means if I took x minus 1 and I set it equal to 0 and I solved it for x, and I did synthetic division, so a factor means the remainder is 0. So on this particular problem, I do think it would probably be easier to do synthetic division and prove that the remainder is 0. So if x minus 1 is a factor, then you have to set x minus 1, since it's a factor, equal to 0, solve for x, use that answer for synthetic division, and see if we get a remainder of 0. 1 times 1 is 1, combine 0 times 1 is 0, combine negative 4 times 1 is negative 4, and we do get that remainder of 0. So we can check this. The second answer says if we substitute in negative 1, we get a 0. That means the same thing as if we do synthetic division with a negative 1. Now we did it with a positive 1. So if we do synthetic division with a negative 1, let's see if we get a remainder of 0. So bring down 1. 1 times negative 1 is negative 1. Combine negative 2. Negative 2 times negative 1 is positive 2. Combine negative 2. Negative 2 times negative 1 is positive 2. Combine, and we get a remainder of 6. So that means that f of negative 1 is not equal to 0. This says f of x is divided by x minus 1 and has a remainder of 0. That's exactly what we did in this first step. So this is true. And this says f of x is equal to 0 when x is equal to negative 1. And that's not true. F of x is equal to 0. This is what we did here, and we did not get a remainder of 0. So on this one, we're going to say x minus 1 is a factor. And then we're going to say f of x is divided by x minus 1 and has a remainder of 0. So you could try this one out, but you're not going to get a remainder of 0. You're going to get 6. It says, what are the factors of the polynomial? So in a previous problem, I was able to use grouping, factoring by grouping. This is not going to work, and it's not going to factor on its own, because if I group the first two and the last two, I'm not going to get a common group. But it is giving you a little hint here. It says use the rational root theorem to determine the factors. Okay, use the rational root theorem to determine the factors. So that's a formula. That's a good thing. So the formula for the possible rational roots is you're going to take, it's going to be plus or minus, and you're going to take the factors of your last term and divide those by the factors of your first term. So that's going to look like this for this problem. Negative 15, let me erase this. Negative 15 is my last term. It really doesn't matter whether that's negative or positive. So I'm just going to use 15. So the last term is 15. Let me write that here. The first term is 1. So I've got factors of 15. That's going to be 1, 3, 5, and 15 divided by factors of 1, which are 1. I could have more factors on the bottom, which would produce more possible rational roots. I just do 1 divided by 1, plus and minus. 1 divided by 1 is 1, 3 divided by 1 is 3, 5 divided by 1 is 5, and 15 divided by 1 is 5. So your possible roots would be positive 1, negative 1, positive 3, negative 3, positive 5, negative 5, positive 15, and negative 15. We could do synthetic division for every single one of these, and what you're looking for is you're looking for a remainder of 0. We could do that. I think that's probably a longer way. So we could possibly use synthetic division. And then we would use the 1, the 7, the negative 15, and we would divide by each one of these numbers until we got a remainder of 0. Okay, so we could do that. Okay, or we could use our calculator. So we would take our function and we would put in positive 1. So I'm going to do what that would look like in your calculator for 1. That would be 1 cubed plus 7 times 1 squared plus 7 times 1 minus 15. And we would be looking for a 0. So on this one, I would suggest using the calculator. Okay. And so what I got here is I got -1, I got -3, and I got -5. So you could use synthetic division, looking for a remainder of 0. Let's talk about 3 ways. You could use your calculator and plug in all of these, okay, or you could take this equation and put it into Desmos and see where it crosses the x-axis. That might be even faster. So let me show you that really quick. I can only record for 30 minutes, so I'm always having to be fast here. So what have we got here? X cubed plus 7x squared, x cubed plus 7x squared, forgot my x, plus 7x minus 15, plus 7x minus 15. So what you'd be looking for here, remember solutions and zeros and roots are where the graph crosses the x-axis. So you got -5, -3, and +1. And I think we should have those circled. -5, -3, and +1. And remember, those are the solutions. So you have to go back and think about what the factor would have been. So to get 1 as your solution, the factor would have been x minus 1. To get -3, then the factor would have been x plus 3. To get -5, then the factor would have been x plus 5. So you got to go kind of backwards a step. So x minus 1 is a factor, x plus 3 is a factor, and x plus 5 is a factor. So you kind of had 3. You could do synthetic division, look for remainders of zeros. You could use your calculator, plug in each one of these numbers, possible rational roots, until you got a 0. Or you could use Desmos and look for where the graph crosses the x-axis. Number 7, one of the zeros of the polynomial is 3. Sometimes I forget that the problem gives me a 0. So we're going to start by taking 3 and do synthetic division. We have to use synthetic division at least once here. So my coefficients are 1, -1, -7, 1, and 6. 4, 3, 2, 1, 6. I don't need any 0 placeholders. So I'm going to go through the synthetic division process. 1 times 3 is 3, combine 2. 2 times 3 is 6, combine -1. -1 times 3 is -3, combine -2. -2 times 3 is -6, combine. And we should get a remainder of 0 because they're telling me that 3 is a 0. So if you don't get a remainder, okay, of 0, something's wrong there. Now we're going to write this polynomial. So we're going to go up to the degree, the highest degree, 4, and we're going to subtract 1. That's going to give us a degree of 3. So this 1 represents 1x to the third, and then the 2 is the x squared, and the minus 1x, and the minus 2. And then what I'm going to hope from here is I'm going to hope that I can group the first 2 and the last 2 and factor by grouping. So I'm going to go ahead and check my GCF that the first 2 terms is x squared. That's going to give me x plus 2. If I factor out a -1 from the last 2 terms, I'm also going to get an x plus 2. So I can finish this problem up by just using the method of grouping, factor out my group, which is x plus 2. That leaves me with x squared minus 1. The x plus 2 will not factor again, but the x squared minus 1 is the difference of squares. And it'll factor into x plus 1 times x minus 1. And this is the part sometimes we forget. But since they gave you one of the zeros, then you've got to remember to add it in as a factor. And if it's +3, then that means the factor would have been x minus 3. And then these would be your 4 factors. So we got x minus 3. They could be in a different order. We got minus 3, plus 1, minus 1, and plus 2. I think it's this one. This means we have 2x minus 3's because it's squared, and we don't. So let me move on from here. Let me see how many problems I had. I have a class about to start. All right, let me get through. I've got time. Okay, on number 8, it says, what are the zeros of the polynomial function? So I would suggest putting this into Desmos and seeing where it crosses the x-axis. So I'm going to suggest Desmos for this one. And again, you're looking for x-intercepts, where the graph crosses the x-axis. On this one, I got -5. I got -1. I got +1. And I got 3. Enter the number of zeros for the polynomial function. On this one, I would also suggest that you put this into Desmos, and you're looking for where the graph crosses the x-axis. And this just wants the number. So you're looking for the number of times the graph crosses the x-axis. Again, I don't have time to put it in right now. I've got a class that's about to start. So 1, 2, 3, 4. This is not what the graph looks like exactly, but it does cross 5 times. And you would it just says how many. It's not wanting to know exactly where they cross. This one says factor completely. This is a trinomial. So I would start out using my knowledge of factoring trinomials. My last term is negative, so that means my signs are going to be different. Since this is an x to the 4th, I have to use an x squared times an x squared. I need my middle term to be +3, so I need my 4 to be positive and my 1 to be negative. And then each one of these factors again. This one factors into complex factors, x plus 2i times x minus 2i. And then this is the difference of two squares. It's going to factor into x plus 1 times x minus 1. So I think it's this one. X plus 1. Nope, that tricked me. That's 2 x plus 1's. X plus 1, x minus 1, x plus 2i. Yep, it's this one. X plus 1, x minus 1, x plus 2i, x minus 2i. Awesome. All right, that was my last example. Hopefully this will help you with any quizzes in Unit 4 or your Unit 4 test. Let me know if you need any extra help. Thanks.